All right, so in this video, we're going to introduce the idea of a parametric curve. And this will be the topic that we're covering today in class. So I think the best place to start is coming from what we already know. So from the past couple years in math, we've seen functions always been represented where we have some function that is a function of x. So for example, we feed that function an x value and we get back a y value. So we could see a plot like this thing on the right-hand side here, where this function of x is some function where for every x value, there is one specific y value. Now, why does this matter? Well, our functions in this type of definition are actually somewhat limited. So for example, as briefly mentioned a second ago, in order to be a function, what this function needs to satisfy is the vertical line test. And the idea for the vertical line test is if we just put a vertical line through any x value, we're only going to touch this function at one point. And if that's true, then we can call this a function because one x value corresponds to one y value. Now, for us today, this idea of parametric curves actually allows us to go further. Because, for example, I'm going to just draw a spiral down below. And what I want us to think about for this spiral right now is, what if this is just tracing how we're walking around kind of on the floor? So for example, we have a starting place. And then from this starting place, I'm just, kind of walking in a circle, but extending out into this spiral pattern. So this function, or this curve, I should say, is my walking around this room. Now, there's nothing crazy about us walking around a room, but if we try to ask ourselves, is this a function? We put a vertical line through that, and we see that, well, that vertical line touches our walking trajectory at 3 different spots. So this fails the vertical line test, so we can't actually represent this as a function. Y is a function of x. So when I'm about to write y is a function of x, that is not allowed because this fails the vertical line test. So there's nothing crazy though about how we just kind of walked in this spiral pattern. So why can't we represent this with some type of mathematical construction? And that's actually where this idea of parametric curves comes in. We basically say, you know what? Rather than restrict that for every x value, there's one y value. What if we had both the x and the y coordinates of our curve at every single point themselves a function of some other parameter? So for example, if this really is us walking around a room, as we walk forward, basically what's also happening as we're walking is time is also marching forward. So as we're marching in this kind of spiral pattern, time is marching forward, but as time's marching forward, both our position in x is shifting differently, left and right, and our position in y is shifting up and down differently. So we can think about both x and y in terms of our positions changing with respect to time. So that's actually what a parametric curve represents. It basically says, you know what? I'm thinking about my x position as a function of time, or t. I'm thinking about my y position also as a function of t. So therefore, as t changes or time changes, I'm getting different x and y values back. So we can think about this entire thing as a parametric curve, where this value t is what we call the parameter. And it always helps me to think about this t value, or this parameter, whatever this third kind of thing is, as time. Because I know as time changes, I think about x and y values also changing with respect to time, just as though we're kind of walking around or moving around a room. So the notation for parametric curves, we can either write sort of in this curly bracket notation, or in kind of a more familiar kind of coordinate field, where we have x and y as though they're coordinates, but we have them as functions of that parameter t. So this item down here actually defines a parametric curve for us. As long as we're given what the function x of t and y of t are, then as t changes, the x and y coordinates change, and our curve will also move around, or will move around that curve. So what we're going to do today is kind of go back and forth between how can we represent parametric curves, or how we can plot parametric curves to get stuff like this spiral on the right-hand side, as well as how can we go from that spiral back into these individual equations for both x and y of t.